master's degree and doctoral degree in the US. I graduated from Cleveland State University in Ohio, which is not far from here. My major is electrical engineering. I'm teaching electrical engineering related courses like circuits and some programming. And okay, why engineering? Well, engineering is fun. It's no problem. Favorite food or fact? Another food. I like sweet food, like chocolate. Fun fact. Let's see. Well, let's think. I like what? I like to walk sometimes. Fun fact. Okay. Well, that's about me. Can you please also introduce yourself?
Good morning. My name's Steve Doucher, and so my history is varied. I am the proverbial jack of all trades, the quintessential adult learner. I have studied a multitude of things. I have an associate's degree in tool and die making. I have a bachelor's degree in industrial technology, which is essentially a systems degree within the Department of Engineering. I have a master's degree in sport administration. I have all but 3 credit hours of a master's degree in rehabilitation administration. I have a doctorate in education. I have taught for the military academy for the state of Indiana, the state of Florida. I'm an instructor trainer for the American Red Cross in, at last count, 35 different disciplines. And so I enjoy learning. I enjoy helping other people learn. The reason that I'm here at Taylor is that this is an opportunity for me to put together a lot of the different things that I enjoy doing. And I love to create, I love to problem solve, and that's what this is all about. My main job here at the university is to supervise the engineering project shop. And so as you continue on through the engineering program, you will see a lot of me. We are adding courses. We just added an introduction to machine tools last semester, which allows students to actually learn how to operate a milling machine, a lathe, and various other fabrication tools. And very well received. I think we're going to do some more of that type of thing. I also teach rapid prototyping for the computer science side, and I teach systems courses, which basically looks at everything as a system. And you'll get just a brief taste of that. I think tomorrow or the next day I have a lecture that will kind of introduce you to systems thinking and how you can use that information to help you as you go through this program. Oh yeah, and it's 27 years in the United States Army, retired as a captain, and I'm also an Ironman.
So I'm Josiah McClurg. Oh, there we go. Hello, students watching. I took some correspondence courses when I was in high school. So let's see, about me. I have a degree in electrical and computer engineering, so the computer programming, the electrical stuff. But I'm also interested, one of the reasons I wanted to work at a place like Taylor is because of the interdisciplinary program that we have here. So I'm really interested in the interface between electrical and mechanical systems. Why engineering for me? I wanted to do engineering because I wanted to help people. So there's a lot of technical ways that you can help people in the world, and that's why I chose this. It ended up being that the way that God wanted me to help people, at least right now, is via teaching. So that's why I'm doing teaching. So favorite food or fun fact? favorite food is probably, I don't know if coffee counts as a food, but I really like coffee and all things related to coffee. It's also fun, if you ever want to roast coffee on your own, you can do it. You just need an oven. So if you can make popcorn on the stovetop, you can make coffee. Roast it. There's, fun fact, I can play the Appalachian dulcimer. So that's my favorite. How about you guys? Let's maybe go around the room and just quickly say why engineering and like a favorite food or a fun fact.
What if my name wasn't called?
Oh,
That's a great thing.
yeah, we'll just have to write it down.
Write your information there. Name,
Yeah, we can get
email,
registration
all that good stuff.
issues worked out.
Did you just add in the last couple days?
Yeah.
Okay. Anybody else whose name wasn't on there?
What else do you need besides name?
Email.
All right. I also print this signature sheet, so I will give you this. You'll sign your name later. But you do not have a group number yet, so let's form groups first. All right. Okay, for the JTerm, you are going to have classes every day for about 16 days. And it's kind of going to work. So you go to work every day, work on a project, working in a group environment. The course will keep you busy, but it's not super difficult or anything. The pressure may come from making the final product. So plan ahead and plan how to finish the product. That will help.
Can I just say one thing?
Yeah.
So this point here is really important, and it's not something you're used to. So you've done group projects before, probably in high school, but you're almost certainly not used to early detection and decisive addressing of dysfunction in a group. So we are here to help you. Your team does not have time to have a member of the team who is not pulling their weight. So you need to come to us, and we will not get people in trouble. It's not going to be, a bad thing. It's going to be something that's necessary for your team to finish on time. So we're there to help facilitate the team working well together. So you need to come to us early as soon as you detect any sort of dysfunction in the team.
Right, and just kind of tab onto that. You're not going to be able to accomplish everything during the class period. All right, there's just not enough time. So you'll be doing a lot of work outside of class. All right, and so a good team leader will assign projects for people to do. Okay, hey, you've got this piece of it, I've got this piece of it, and so forth, right? And so if there's some dysfunction going on with your team, the sooner that we know about it, the sooner we can take corrective action so that everybody will have a successful outcome.
And one way you can detect that is actually, are you having fun? If you're feeling like you're always it's a painful experience every day, there's probably a reason for that. So think about why it is, and come talk to us about it, and we'll help maybe detect some of those problems and work them out before they start to be a week in and the semester is already 3/4 of the way over.
Right. And then also, we're throwing a week's worth of information every day. So it's not going to be something where you can just absorb it and you got it, all right? Unless you're just one of those people, which I am not. I don't think any of three of us are either. All right, tremendous amount of information. So take good notes, all right? I've seen one person with note-taking material. Yeah. Okay. All right, 2. Where's your pen? All right, you really have to take notes, guys. All right, we're going to make slides available to you. These videos will be available to you as well. But if you're not taking notes, you're not actively engaged in what's going on. All right. Research was done 25, almost 30 years ago, all right? The more senses that are involved in the learning process, the more you retain. So just watching a video, listening to us talk, you retain about 5%. All right? If you're interactive, you're taking notes, you're listening, and you're talking back to us, feedback, all right, you can get upwards of 65 to 70%. All right? It would behoove you to be in that 65 to 70 percentile.
Okay, learning outcomes. There's a lecture every day in the morning. There's a live in the afternoon. For the lecture part, we will talk about general ideas about the course. General meaning how to manage the project, how to design the project. Not many technical details, but we will talk about how to build things in the afternoon. So let's see outcomes like iterative design, how to design something in this way, and interdisciplinary work. We combine computer engineering, electrical engineering, and mechanical engineering together in this course. You will learn how to use laser cutter, and how to design 3D model, how to use Arduino. Did anyone use Arduino before? Okay. You hear about that before? Okay. How about Raspberry Pi? More people? Okay. They are similar. It's a circuit board for programming. And it's easy to use and it's fun. Okay. You will also learn Eagle, that's a circuit design software. You will learn project management, how to write good reports, how to do presentation, and how to use Excel for graphics, and so on. Any questions about outcomes? There's a lot of information, but we will talk about details later. All right, so our plan is to make prototype for the final product. For example, in the first week, you will learn the basic stuff, and then do a prototype, hopefully. And we have guest speakers in the class. The guest speakers are Taylor alumni, or some people who have cooperation with us. And they are actually the managers in industry. They will talk about what the expectation for the employees in a manager perspective. So when they talk about their topics to us, it's a good opportunity to ask them questions and see what do they expect in the workplace. So that's the purpose of the guest speaker. Questions about the guest speaker? We invited 5 guest speakers, so they will talk about different topics. Well, to make sure you can get the final product done, we have a midterm presentation. So about 2 weeks, we expect you have some results for the final product. But it's not the final one, so you just show us what you have. So that's midterm presentation. Let's see, well, last, you will have the final product and do some testing on the thing, like how it works. Is there any improvement or something like that? Again, we have different guest speakers. Some of them will stop by in person, some of them will talk to us by Zoom. So later we will maybe just...
I think I must have forgotten one of them.
Huh?
I must have forgotten one of the speakers.
Oh, okay.
But we'll fix that soon.
Well, that's no problem. Also, I can post the LinkedIn profile of the speakers. So
Yeah, and it really is worth you guys looking up some of our speakers, so you can think of good questions to ask them, because this is a good opportunity for you to interact with real engineers who are interested in helping Taylor students. They wouldn't come here if they weren't interested in actively helping and engaging with our students. So it's worth getting your questions answered.
Right. And if they are willing, you can send emails to them and see if there are any internship opportunities. Right. That's a good thing. Great. Okay. Okay. First, attendance, 5%. So you stop by, you sign your name, you got 5% for free, kind of. Cleanup. You will work in the lab most of the time during the live session or after live even, but it's important to keep everything organized. Okay. It doesn't matter you work in the circuit lab or the mechanical shop. You need to clean up everything after you are done. So you will use some equipments or materials from the drawers here and there, but you make sure you put everything back to where it's from.
Let me tag on there. So when you're working on your project, right, this is going to be an ongoing thing for the next several weeks. All right, and so you're going to be using tools, you're going to be using materials, and all that stuff. All right, when you come down to my lab, the lab is clean. All right, when you leave my lab, the lab will be clean. The same will be said for the electrical lab. All right, if you leave a mess, all right, I'll know who it is, and I will deduct points. All right, because this is how it should be in industry. When you go to industry, all right, you don't just leave a mess laying out on the desk somewhere, okay? You don't do that, all right? What we're trying to do is start you early on good habits, good work habits, all right? And so at the end of every session, take 5 minutes, clean up your mess, all right? If you have a project that's in progress, all right, you set it someplace in an organized manner, all the tools get up, you put all the stools back, you sweep, you wipe down your work area, and then you go. All right, that's the standard. All right, and
yeah, we basically don't want to be, we don't want to be like your mom or something. Like, we want you to be adults. We trust you. We want to continue trusting you. Just don't give us a reason to have to be like. We always have this deep sigh inside when we have to go deducting points. So don't
make us do it.
Don't make us do it. We don't like to.
Right. That's kind of 3 points with not much effort actually. Okay, now performance. We will evaluate your performance. You're working in a group. Are you making efforts or not? We can tell over time, right? So make contributions however you can. We will give you individual assignments almost every day. It's for the lab, so it's kind of a lab report. It won't be difficult. So basically, you design something or you do something, and you collect some data, like take a picture of your circuit board or whatever you have, and talk about what have you done for the day. So that's individual assignments. 50%, that's a lot, right? But it's not difficult. The final product is about how it works and what kind of features do you have. Final slides. We're going to do presentation, and the slides is part of that. We want to see if you make good slides. Is your slides easy to understand or not? Final presentation, you'll give a talk in a group to us. Well, imagine that you are communicating with someone who doesn't have engineering background, like your customers or your boss even. They may not understand what you are doing in a technical way. So it's important to introduce what you are doing in language so everyone can understand. Final report is 15%, right? That is group work, I think, right? All right. Well, for the group work, everyone will contribute to the final report, and you will have the same grade. If you are not satisfied with your group members' work, you probably need to contribute more, maybe.
Well, and also come talk to us. I mean, that's what we're here for. And like I said before, nobody's going to get in trouble or get an immediate grade doc. We're going to come in and help facilitate a better functioning team.
Right. And above and beyond bonus, 1%. That means you are doing a really good job on the final product. For example, if we have the requirement of 2 features and you make it 3 or 4 with actual function on the final product, that's above and beyond. Course evaluation, there is one course evaluation at the end of the semester, so please do that. For continuous improvement, and team leader bonus 1%. Well, the team leader is expected to do more work, to organize the whole group, to assign small assignments to everyone. So kind of something like that. Questions about the grade? No? Okay. Okay. So let's see the project. You are going to design a sorter for the whole course. You can sort different things like coins or marbles or whatever you are interested in. Okay. Why do we pick this topic? Because it's a good integration of programming, electrical circuits, and mechanical parts. Well, if you have some other good ideas, you can also talk to us. So, but so far, sorter works really well. If you design a robot or something, that's also an integration of mechanical programming and the electrical, but it's gonna take more time, we assume. And if you build a robot, cars or something, it's going to run around. That's not very good way to evaluate the project. So sorters works well, but if you have good ideas, please share with us.
So to kind of give you a background on how we came up with the sorter, right? 5 years ago when I first came here, this class did a skittle sorter, right? And so the scope of that was that they already had the basic design and they made small tweaks to that design and they just kept iterative designing it each year, all right? 3 years ago, we decided that we wanted to give the students more discretion in what they did, all right? And so what we've come to is that you guys decide what it is that you want to sort. And we've had people sort gummy bears, fruit chews, Jolly Ranchers, coins, Skittles, obviously. And so you can sort whatever it is that you want to do. And so we allow you to do that because if it's your idea, you're going to be more invested in it and you're going to devote more effort to that process, right? So we ask you to sort by 2 criteria. So typically one of those criteria is a color, all right? And the reason that it's a color is that we want you to go through the process of coding for color sensors, right? And to think about that. So you can also sort by shape, by weight. There are a lot of different things that you can do. So these are just a couple of different designs that have been done. And
This one's a dice sorter, and this one is a
Yeah. So you have a lot of flexibility in what you do, all right? Now, so we're asking for you to be able to sort by 2 physical criteria, right?
So
Above and
please-
beyond, you could
Please
do
don't
3.
Please don't do like something really complicated like viscosity. That's
Right. Last year we had a group that sorted, they were some kind of fruit gummy, and they sorted them by weight, all right? And when they proposed that idea, we were just kind of like, ooh, I don't know. They pulled it off. It actually worked. And, you know, they were really thinking outside the box. We had another year where the students were wanting to sort, and I forget what it was, but essentially, there wasn't a sensor that was readily available for that. And so Calvin Oakes, some of you may already know him, all right, he developed his own sensor. And if we have time, I might have him come in and talk during one of the mechanical labs, all right, because he does a really good presentation on how he arrived at what he's doing, all right. But this gives a lot. I mean, you can see how complex this is, but it doesn't start out this way, right? How do we do this? Well, that's what we're going to talk about. All right, tomorrow's lecture, I'll talk about how do we start from the beginning and arrive at something that's as complex as this.
Thank you. All right. Any other good ideas about the project? Like you want to do something else other than the shoulder? You can think about it. All right. We will evaluate your final project in these aspects. How it works. Is it meets the requirement? How about the efficiency and the cost, or something like that? Okay. Groups. We will have small groups. I think we have 21 students.
yeah. So basically, just so it's clear, the groups that you form right now are not going to be your final groups. The groups you're forming right now are going to be groups to generate at least 2 project ideas. We're going to list, once your team or your group has generated 2 project ideas, just tell them to us and I will write them on the board. I'll give each one a number. And then at the end, we're going to have a little online quiz where everybody goes and they say, these are my top 5 or my top 3 numbers of projects that I like. And we'll assign groups based on the projects that people are interested in rather than just on whatever you randomly pick. So that's the way it's going to work. Don't think that this will be your final group.
Thank you. So we will probably have 3 students in one small group. So we have totally 7. Right. Okay. And as small groups, also we have a big team because the space limit of our life. We will have to split you to 2 big teams. So one team will work on the electrical light, and the other team will work in the mechanical light, and then you switch the second day. So for example, if you work in the electrical light today, you are going to work on the mechanical light tomorrow.
Like let's say that your group is named Group Amazing. That group would be a member of Team A, and Team A would have several other groups. The way the labs are going to work is
And well, I can pull out.
oh yeah, you got it. So
I'm opening the Moodle right now.
So
By the way,
which lab you go to will flip-flop on each day. We'll remind you on the first couple of days, so don't get too worried about it.
Do you have a Moodle account now?
Yeah, can everybody log into one of these computers? And I'll get up so
So
if you need.
the login on these will not be your Taylor login. It will be the one sent to you by Mr. Larian or Mr. Slauson.
Yeah, and if you don't have that, we can just go upstairs right now and we'll get it set up. So yeah, there's a little quiz. If you scroll down to Unit 1, it says Project Vote and Leadership Self-Assessment. So there are two things that I want you to do on this quiz. Thing number 1, I'll show you what it looks like. Thing number 1, type in your first, second, and third choice project. So that's just the number, like 1, 2, 3, 4, 5, 6, 7, 8, whatever. Then there's this little leadership self-assessment score. So before you start the quiz, there's a little leadership assessment that I want everybody to take. Now, don't put too much stock in this. Like if you get a low score, that doesn't mean you're a bad leader. I get a pretty low score on there consistently. So maybe I am a bad leader, I don't know. But it just gives us a rough estimate of like, sometimes people will say, I don't really want to be a leader, but then they rank really highly on this. And it works out in the mix for, it'd be really nice if they would be the leader. So sometimes those kind of situations happen, and that'll just help us pick leaders. But yeah, don't put too much like mental stock in that. It's just a tool. So then you're just asked to rank your sort of ability to be a leader, and then also your willingness to be a leader. And you can decline being a leader if you don't want to. But the benefit is you do get that 1% bonus for being a leader. So, okay. Does everybody know what to do